All right, so again, thank you all for attending today's webinar, which is Case Studies in Flood Mitigation and Adaptation, Resilient Connecticut Projects in East Haddam and Mystic. My name is Nicole Govert, and I'm a Community Resilience Planner with CIRCA, the Connecticut Institute for Resilience and Climate Adaptation. I'm joined by my colleagues, Mary Buchanan, she is the other Community Resilience Planner with CIRCA, and John Truscinski, who is the Director of Resilience Planning at CIRCA, and who you will be hearing from in a minute. Just some quick housekeeping before we start. This webinar is being recorded, and we will post the recording to CIRCA's website, and then we will send out the recording through a follow-up email. Please keep yourself on mute until the question and answer portion of the webinar. If you do have questions, feel free to put them in the Q&A section of Teams, or save them until the question and answer portion of the webinar where you'll be able to take yourself off mute. Mary will be monitoring the Q&A along the way and answering any simple questions. And then again, we'll open it up at the end of the webinar. If you need CFM credits for continuing education, please email me at nicole.govert@uconn.edu and we will make sure we get those credits to you. Just a quick agenda for today. John Truscinski will be giving an overview of CIRCA and the Resilient Connecticut program. We'll then hand it to Deborah Downey, who is the select person in Stonington, and the Fuss and O'Neill team to talk about the Resilient Mystic project. And then we'll move to John Olin and the Kleinfelder team to discuss the Resilient East Haddam project. And finally, open it up for question and answers. Again, this is a really packed webinar for an hour, so we don't have a ton of time for question and answers. But if there's a lot of people who do have questions and we're coming up on the hour, we can stay on and continue the conversation. So with that, I will hand it to John.
All right, thanks, Nicole. Hello, everybody. Thanks for joining us today for this webinar. So my name is John Truscinski. I'm the Director of Resilience Planning at CIRCA. If you're not familiar with CIRCA, so we are the Connecticut Institute for Resilience and Climate Adaptation. We are a research center at the University of Connecticut. We were set up about 10 years ago to support communities in Connecticut, work with state agencies and other stakeholders to improve the resilience of communities in Connecticut to the growing impacts of climate change, most notably various forms of flooding along the coast and inland, although we also work on issues surrounding extreme heat and other health issues that emerge due to climate change impacts. So the Resilient Connecticut program, this was something that we started back in 2018 and started in Fairfield and New Haven counties. And over the last several years, we have also worked in the southeastern part of the state. We worked in the Connecticut River Valley and the Capital Region. And the goal of the Resilient Connecticut program is to help the state develop a resilience project pipeline. So it's a planning and technical assistance program. So we provide various types of support. In some cases, we work with consulting firms and design and engineering teams to do site scale planning and concept development for projects. In some cases, we do data collection for water levels and flooding, and use that to inform the assessment of flood risks for communities. And we also support engagement, public awareness. We work with our state agencies in Connecticut quite a bit in providing them guidance on different issues that arise from flooding and extreme heat. So that's the Resilient Connecticut program. You can go to the next slide. So as of today, we've worked with most of the regional councils of governments in Connecticut. We just have the northwest corner and the northeast corner that we're hoping to work with over the next couple of years. So we've worked across most of the state to identify what we call zones of shared risk. So these are areas of common flood risk in a particular location. And we use those as kind of the building blocks for what we call resilience opportunity areas. So these are places that have a need for additional support to develop projects. And so to date, we've identified 177 resilience opportunity areas across the state. And then we've done more site scale planning in 14 of those resilience opportunity areas involving 18 municipalities. And so today, what we're going to do is we're going to hear a little bit more detail from two of the teams that are working on those site planning studies. So the first is going to be in Stonington, Connecticut, the Mystic section, downtown Mystic section of Stonington, Connecticut, which has been experiencing flooding, due to coastal flooding issues and is vulnerable to sea level rise impacts. And the second one is a riverine flood risk project in East Haddam in the village center along the Sucker Brook and the Connecticut River. So with that, I am going to pass it over to Deb Downey, who is with the town of Stonington, to kind of kick us off with a little bit of the town's perspective about the flooding issues in Mystic and their participation in the project. So take it away, Deb.
Thanks, John, and thanks everyone. I'm happy to be here today on behalf of our Board of Selectmen and others in the town who've been working very hard with Fuss O'Neill and CIRCA on this project. Mystic's a unique area. It includes portions of two towns, as well as historic, culturally significant residential, commercial, and industrial areas. Its proximity to the sea, the river, and various tributaries are both the source of its charm and now the source of ongoing damage. We've become more recently aware that for decades, Mystic and the upstream areas continued to develop and expand without much understanding of future impacts. Sometimes temporary structures became permanent with no regard for tidal reality, or regulations required extra large parking lots at some commercial businesses. Amtrak has also altered the shoreline, focusing or constricting flow in some areas. The presence of multiple buildings, continuous areas of pavements, and other impervious surfaces have accelerated the extent and the incidence of coastal and inland flooding. These concerns are coupled with the presence of important infrastructure and cultural resources along the river and coast. One of the most vulnerable is our wastewater treatment plant on Edgemont Street near the confluence of the Mystic River and Mystic Harbor. I grew up in Connecticut and spent a lot of time in Mystic and Stonington, and in the past, except for major hurricanes, we never saw the kind of flooding that we've experienced in the past decade. We have frequent flooding in downtown Mystic and on the outskirts of the village on locations on Route 1, Route 27, and Masons Island Road, just to name a few. Flooding impacts are not just limited to Mystic in town. We are also seeing more frequent flooding in Pawcatuck, Old Mystic, and in Stonington Borough. Coastal flooding seems to be related to both major events like Hurricane Gloria and Superstorm Sandy, seasonal storms, including a winter storm in January 2024, and then king tides. Some flooding is a combination of both coastal and upland, the upstream impacts, like the Old Mystic flood in 2010 that washed out the bridge between Stonington and Groton. We're also seeing frequent flooding associated with the backup of storm drains in the storm drainage system. To date, the CIRCA project, which has included community involvement and collaboration with town staff and officials, has provided us with a clear study of the dangers we face and some ideas of what we might expect to see in the future. It's a good start, and we've been presented with some aspirational concepts, including interesting ideas proposed by landscape architects, which could be targets for future projects and long-term planning. Many of the ideas include major projects like relocating buildings or raising Route 27. We're also hopeful that the study will offer some ideas for smaller projects and short-term plan, including some concrete proposals, maybe linked to funding sources. We'd like to get started with baby steps initially. and make some focused and localized improvements in the near term as we continue to plan for the future. We're also hoping for some ideas and specific proposals for things like pumping stations or stormwater transfer facilities or changes to drainage, which might stand a better chance of getting voter and board of finance approval. Thank you.
Thanks, Deb. That was an amazing summary of so many different issues and how they all come together in Mystic, and why this is a really critical study, and also why it's very, interesting. And we've been very passionate about trying to work in Mystic. And so I want to pass it over to our consultant team, our partners at Fuss and O'Neill, who have been leading the design aspects of this study. So take it away, Beth.
Thanks, John. Hi, everybody. I'm Beth Kirmmse, and I'm the project manager for the Resilient Mystic study that we're doing on behalf of, or that we've been hired by CIRCA to do. I also want to introduce Andy Boehme. I'll let you come up, or do you want to introduce yourself?
Sure. Yeah, hi, I'm Andy Boehme. I'm a landscape architect and director of landscape architecture at Fuss and O'Neill.
Thanks, Andy. So we'll be splitting the presentation today. Slides are showing all right?
Yep, looks good.
Just a check-in. Thanks, everybody. Okay, so thanks, Deb, for that great introduction to the conditions that Mystic is facing today. And let's see if there we go. Mystic really is facing accelerated, noticeably accelerated conditions of flooding. And I know that the Mystic Seaport Museum has reported that in the last 4 years, they've flooded more times than they have in the 40 preceding years. And so these conditions are of growing concern. And so we're hopeful that we can help outline through this study both the short-term baby steps that the town is looking to implement right away that lead to a long-term strategy that brings Stonington all the way through to end goals that might be 75 years out in the future. We had a robust team looking at this project from the get-go, and the 4 pillars of that team are the team at CIRCA, the group from the town of Stonington who have been dedicated to this project, the Citizen and Technical Advisory Committee, which has been instrumental in helping to shape these ideas, look at data together and to inform the project team, and then our consultant team here at Fuss and O'Neill, most of whom were in residence in Mystic just a couple of weeks ago to deliver a robust community engagement process, which involved a number of events. When we started this project, we were very much aware of its position within the region as part of a number, or as one of many efforts that are being put forth or that have been recently completed in the area to think about resilience in the Mystic River watershed and the surrounding areas. So, for example, Groton was funded for a similar study, which wrapped up January of 2024. And so we started this project amongst a number of things going on, and have sought to coordinate with them where appropriate, in particular through the involvement of the CTAC, that Community and Technical Advisory Committee. So understanding the risks. The project itself, the bounds of this project, we are looking at the most vulnerable areas of downtown Mystic on the Stonington side, the low-lying floodplain areas. There are many critical facilities in this area, critical transportation infrastructure, 2 major state roads, an evacuation route, as well as the the Amtrak corridor. So much of this project is at elevation 10 and below. So much is at risk. Much is at the in the floodplain. You can see with this topographic depiction that the heavier green represents the areas that are in that lower area, which correlates pretty closely to our project bounds. So when we when we started this project, and something that is really important to put forth at the beginning, is that this project looks primarily at sea level rise and tidal flooding and storm surge flooding. Flooding risk that is coming up the river from Long Island Sound. We are very much aware that there is risk from pluvial flooding coming down the hillside that we were just looking in that last slide at in the lighter green tones. And so we recognize that any solution that is put forth will need to be tested for its applicability to mitigate risk to both types of flooding without exacerbating one or the other. Still, our study is focused primarily on what you see in that dashed line. So what are the risks? So what you're looking at here is the, and I'm sorry, my screen just glitched for a minute. I apologize. Let me just bring that back. Apologies. It disappeared here. Oh, I'm so sorry. Okay, so these maps, of course, I know many of you are familiar with the annual exceedance probability flood of the 1% and the 10%. On the left, you can see the 10% AEP flood and its extent under current day flooding. On the right, you can see the 1% AEP flood according to current day flooding. And now the colored shading on the map, of course, represents the flood depths. Okay, I didn't make the same mistake that time. So with my keyboard, great. So now we're looking at the future flooding. And so we have taken CIRCA's model and applied it to the map. And you can see that the 10-year storm scenario expands significantly with 20 inches of sea level rise. Well, this is really exciting. Now my cat is joining the webinar. We're just going to keep rolling here. So this map shows the mean higher high water in downtown Mystic with the addition of approximately 3.3 feet of sea level rise. Now this represents the upper bound or 95% confidence interval of the likely range of sea level rise in 2100 for Long Island Sound. As you can see in this map, the conditions that you saw in the last map where the higher flooding risk was starting to connect the Mystic River across the southern bounds here, Washington Street, up to the northern bounds here of Cottrell Street, but that it's trying to make this connection through there. So additionally, as we know, there are conditions in our built landscapes that exacerbate flooding, and those conditions are represented by a full range of impermeable surfaces. Those impermeable surfaces tend to contribute to extreme heat events as well. So in looking at the flooding risk in downtown Mystic, we're also able to look at the extreme heat risk at the same time. And when considering nature-based solutions, we're hoping to provide mitigations for both. So what's at risk? So we're looking at a map of the Mystic River area. This is showing our project area in the floodplain, bound by the upper, the hillside on the right. And this is 1879, and much of what we're looking at now had already been manipulated. The landscape had already had experienced infill, development, and in many cases, the armoring that persists today. Certainly it's been rebuilt, but its footprint is very much the same. So flooding in Mystic can cause physical damages to the structures and their contents, the human impacts such as residential displacement and injuries, direct or indirect business impacts, and the reduced functionality of public and essential facilities such as fire stations, rehabilitation care facilities, and churches. So this map that we're looking at shows the vulnerability in a 1% annual exceedance flood event to a variety of land uses. So residential is in yellow, industrial in purple, and commercial in that pinkish color. Coastal flooding in downtown Mystic also brings severe impacts to critical transportation corridors. Route 27 is an evacuation route. Route 1 is a very important corridor between Groton through coastal Stonington and the southern edge of the town of Stonington. And additionally, the Northeast Corridor trains stop in Mystic daily, and you can see the train station icon here. Here's the Northeastern Regional Rail line. So what are the regulatory areas that we have at in this area as well? And we wanted to be cognizant of all of the different overlays and the different permitting processes that would need to be engaged in order to mitigate risk to flooding. So we're looking at a federally regulated channel, wetlands on the National Wetlands Inventory. There are FEMA zones. There's a town managed shellfish bed, etc. So as we map this and we were thinking about critical infrastructure at risk, of course, there is the wastewater treatment facility, and there's the storm drainage, as well as public drinking water supply lines, all of which are separate services, but all at risk. And when they are at risk, could end up impacting one another. My cat would really love to be a part of this webinar. Sorry. Additional critical community assets were assessed through the planning phase of this project, the assessment phase of this project, and we identified a number of facilities. Most importantly, that hot pink dot number 4, the wastewater treatment facility. We also looked at the historic resources at risk. Now, there are a number of historic districts that surround this area, but it is of note that the downtown area in our project area has not been part of a district overlay, although there are a number of facilities in that area that are on the National Register of Historic Places, which is a federally recognized designation.
Beth, I just want to let you know you have about 5 more minutes.
Perfect. I'm about to hand it over to Andy. So I will hand it over to Andy for the workshop summary.
Thank you, Beth. So the workshop, you can go to the next slide. So the workshop was really designed to be an inclusive engagement event that allowed as much access and opportunity for the community at large to kind of be a part of the process. You can go to the next slide. This was done over a period of 3.5 days with a variety of workshops, walking tours, visioning exercises, open houses, and then a final presentation. You can go to the next slide, Beth. You can just kind of click through these. So this is there's some representation of some of the workshop events that we had, the information that was gathered, different focus groups that were integrated into the workshop. You can go to the next ones. We do a lot of visualization boards, really trying to engage the community in a sense of design language. So we ask people to kind of weigh in on the intent. You can go to the next one, Beth. With the red dot, green dot for different areas to get a gauge for what people like, what are they interested in seeing, what does the aesthetic look like, so we can start to use this, and you can flip through these in a variety of different ways. Very good engagement, really good feedback. Got a lot of community involvement. Beth, the next piece is the historic resources. Do you want to jump into that?
Sure, I'll just touch briefly on this. So, as I mentioned before, there are many National Register listings in Mystic, and so we look to ways to think about, what has come before in terms of other places addressing the same thing. We looked specifically at Charleston, and we looked at Newport. We looked at their regulations and thought about small scale adaptation. We thought about flood proofing structures. What would happen if they needed to be elevated? How could you maintain historic character and connection? And then, of course, one of the things that is really important to remember is that all of coastal New England has been adapting for centuries. And so even at the Mystic Seaport Museum, they have relocated many of those buildings there. And so the historic nature of Mystic is one that has changed over time, but each time it changes, pieces of what makes Mystic and gives it that historic character have been held onto, even when they need to be reshaped in order to meet, the last time it was reshaped significantly was to meet changing cultural needs. It was the shipbuilding industry was exiting, but Mystic chose to hold on to some of their historic assets by relocating them strategically.
I'll go through this as quick as I can, but still be concise with it. What I guess generally we focused in on a series of areas to kind of do a deeper dive into understanding what some of the flood mitigation, some of the adaptation strategies might be. In priority one, we looked at Murphy's Point on the south side here, really looked at opportunities for elevation of roads and doing everything we could to maintain critical access to the wastewater treatment facility. That you can just kind of keep flipping through these and I'll roll with it as we go. The next slide shows a little bit of conveying the intent of the road elevations and what this could do to make sure we have access off the site. The next zone that we looked in was just north of that, and really looking at opportunities for, again, elevating roads where we could. Are there opportunities in this zone? You can go to the next slide, Beth. For allowing the water to come in certain respects into certain areas, looking at potential opportunities for strategic acquisition, relocation, moving critical structures out of risk. Also at the same time looking at infill in the same capacity. You can keep flipping through these and keep going. The next area that we looked at was Main Street, and really looking at what we could do to kind of strategically look at infill opportunities that were resilient in the face of these changing climate. You could keep flipping, Beth.
So one of the ideas was to that infill piece where there's a potential change that could be led by zoning regulations. So zoning regulations that are put in place as that baby step now that incent change over time.
And looking at road infrastructure as it is today, and the potential discontinuation for vehicular traffic and converting it to multimodal and pedestrian traffic. You can flip to the next slide, just showing kind of the different graphic representations of kind of what Home Street could turn into, and still allowing those floodwaters in. Priority Area 3 was the Washington Street area, and the town owns the road here. So looking at what elevation could look like in here to give a level of protection. So understanding and kind of exploring what that looks like. If the road comes up, what buildings need to come up to make sure we meet that elevation, to still have kind of that historical context was a key component to that. Also looking at the green infrastructure and the streetscape around this area, and how could we kind of let that water come in over time, but knowing that it's not going to be underwater all the time. So, still using it as a high functioning, high value landscape. And the last area that we looked at was on the north side of the project area, around Route 27 and the Mystic Seaport. The state owns the road here. The Seaport Museum owns a very, very large surface parking lot. So looking at opportunities here to zoom in and provide opportunities for that road elevation. You can flip to the next slide. Road elevation, consolidated parking, potentially a parking structure, lots of green infrastructure, multi-use landscape, allowing this kind of floodable landscape to function, and still potentially being able to convert some of the surface parking lot to kind of a living laboratory outdoor landscape for the community and for the seaport to use moving forward.
Thanks, Andy, for running
Sorry,
us through
that was fast.
They're in-depth concepts, and so we're just hoping to hit the high notes in this webinar. But we do actually still have an opportunity if you want to take a look at our project area, and we're still accepting input from the community. If you want to provide input, we have the project story map, and you just click into open the points of interest map. And in that points of interest map, you can drop a pin and provide us any input that you have, either as a resident, someone that works in Mystic, or someone that visits Mystic. And since tourism is so important, is such an important part of the Mystic project, it's important to hear from everyone, even if you don't live or work in Mystic. So you can see you can upload pictures for the project's use, and this will be handed over to CIRCA at the end and used, hopefully, and to the town of Stonington, of course, used for gathering and positioning future projects for funding as well. So thank you very much for this opportunity to present to everyone. Thank you, CIRCA, for having us join.
Thanks, Beth and Andy. I know that was pretty quick. So again, if you have any questions for Beth and Andy about the Resilient Mystic Project, please feel free to put them in the Q&A now, or again, at the end of this webinar, we'll have a couple minutes for Q&A. So now I'm going to hand it over to John Olin and the Kleinfelder team to talk about the Resilient East Haddam project. So John Olin, if you want to start and briefly talk for a minute or two about East Haddam's experience with flooding and the CIRCA team.
Yes, can you hear me?
Yep.
After hearing about Mystic, in some senses, I'm relieved that we have a lesser challenge, perhaps, and so I look forward to watching your progress there in the town of Stonington, and learning from it, and also if we can be of assistance in any way from what we've learned. But we're your inland neighbors, about 16 miles, as you may know, from the Long Island Sound, and our major problem is flooding from a brook that runs through the center of our village, Sucker Brook. We've been aware of this for decades, really. People talk about the '82 storm and the 2018 storm, and we were a mill town, and as often happens, the buildings were built very close to the brook, and these are giving us some some concerns at the moment. As you may know, East Haddam, like Mystic, in some sense, has a tourist magnet in the Goodspeed Opera, and many of the opera properties are threatened by flooding. So, just a little background. This effort involving CIRCA and other agencies that we've also are looking at funding sources, and are really happy to have so much support for the intense weather that we're all beginning to experience. So we invited CIRCA about 3 years ago to the town, and as part of their 2.0 resilience project. And then shortly afterwards, the Nature Conservancy hosted a climate or a community resilience building workshop, and that brought the attention of the problem to a lot of community leaders. We brought together 25 leaders and who still are involved as in the various public engagements that we've had since CIRCA's project got underway about a little over a year ago. Let me just mention too that what I've personally, as a member of the Conservation Commission, which has been very supportive of this, as well as Sustainable CT and our local sustainability team, I've learned that these problems are not going to go away. We're looking at increased precipitation and also flooding along the Connecticut River in certain sections of our town where we have a wastewater treatment plant in particular, and Goodspeed buildings. And that the solutions are long-term, and specifically Goodspeed's properties include a rehearsal building and actor housing, which is directly been affected over the past at great cost and concern to the Goodspeed musical organization. As well, businesses have been affected by the flooding of Sucker Brook along its course in different parts of the watershed, as well as residences. So, we're in it for the long haul, obviously. The town government is our municipal government is the Board of Selectmen, and as I mentioned, the Conservation Commission is very much supportive of this. We're hoping to see some kind of direct interventions that can prevent the impact of this flooding in the conceptual study that's underway at the moment. And then we'll move on to the next step for funding. And we're also working in partnership with the stakeholders. We've been working with the Goodspeed, their board of directors, or board of trustees, as well as the directors who are responsible for the daily functioning of the organization. And this is a part of the reason why I say this is a long-term commitment for all of us, because the solutions aren't readily available. For example, movement of the moving or raising of the rehearsal hall requires that they have a space where they can continue their operations, and
Hey,
that may
John.
take several years. Yes?
Oh, I'm sorry to cut you off, but I think we need to move on to Neil's presentation just for the sake of timing. But I'm sure Neil will
Okay.
cover a lot of those alternatives that we came up. So thank you so much for being on and joining from Scotland. But Neil, I think we'll pass it to the Kleinfelder team now.
Yeah,
Very
thanks,
good.
John. I'd like to say John's been a great advocate for the town and for the project overall, and fun to work with for sure.
Thank you, Neil.
So I'll jump right into it. So quick agenda, just going to go through a little bit more focused than the previous one. We're going to skip over a lot of the work that we did as part of the overall project, really just focusing in on the modeling that we did and a few of the adaptation strategies, and kind of so you can see from the modeling how those adaptation strategies are working. So just an overview, as John mentioned, this is what we're calling Lower Sucker Brook. It essentially starts as you get into the village here. Sucker Brook comes into the village of East Haddam and ends up coming to the Connecticut River. As John mentioned, Goodspeed is, I'm not sure if you can see my screen, but right, Goodspeed's right here. And here you have the famous bridge over the Connecticut River here. So just to kind of get your bearings. So we're going to focus on the flooding of this Sucker Brook, and you can see all the different really facilities that are affected, whether it be stream crossings or buildings, or over here we have the treatment plant. But today we're going to focus on a couple things as part of our study. The rehearsal studio, as John had mentioned, a real pain point for the town and for Goodspeed. You've got this actor housing in these residential properties that are essentially adjacent to Sucker Brook here, and this Creamery Road crossing, which is a real constriction for the brook overall. So again, moving on here. So just to kind of give you what we're dealing with here, this was our site visit. So this is the rehearsal studio. So as you can see, you've got essentially the stream is culverted beneath the studio. So the picture on the left here, you see is really the outlet of it. On this side, just upstream, there's a small dam here. Again, as John mentioned, it was old mill town, constructed dams and these constrictions to really harness the power of the water. And then down this lower right, this is basically the inlet to that culvert. So real challenging space here. So some of the flooding, as you can see this picture on the left here, that's the inlet side of the culvert back in September 2021. So not that long ago, major flooding of the building and the surrounding properties. More recently, in 2024, you can see this evidence of debris that was up against the building, basically the aftermath of the flooding. And then you can see just really on the, again, that same time frame in January 2024, kind of the inlet side, some of the conditions they're seeing of the brook there adjacent to the rehearsal studio. Let's see here, advance. Okay, I mentioned the actor housing area. So again, here, these properties, some new, as you can see on the left, newish properties built kind of along the within the floodplain of Sucker Brook here, and as well as some historic properties that are affected as well. So again, some of the flooding impacts we've seen from these properties. This is from September 2021. Again, that same September flood, major flooding around these properties and Norwich Road, as you can see from these photos. Oh, I went too fast. And then this Creamery Road crossing, you can see this is a typical box culvert that you see all over the place in New England, right? And you can kind of see just at the normal water level, it's really creating a constriction of the stream, and that we'll see how that constriction kind of exacerbates some of the flooding issues within Sucker Brook. And then we got a couple photos of these are the properties adjacent to and surrounding this Creamery Road area. So again, September 2021 storm, major flooding through this area during that storm. And again, just more recently, again in January 2024, we were able to, see again evidence of overtopping of this culvert. You can see the debris there that was caught up on the surface. That really showed that the whole culvert overtopped fairly recently. So that's kind of that's the overview, and those are the areas we're going to focus on. So now, next I just want to talk quickly about the modeling that we did. So at the beginning, of course, the hydrologic work we did for present day, we used the NOAA Atlas 14 precipitation, and then for our future estimates, we're using the PCSAR predictions. You can see again significant increases here from if you're comparing present day to the PCSAR kind of mid-century prediction. 100-year basically from 8 inches to 12.5 inches. It is kind of notable too that you get late century and actually these numbers go down from mid-century based on the climate models. So what does that look like for flows? Again, so we have present day in this bottom row, and we looked at a few different methods just to kind of, again, calibrate our analysis, make sure we were understanding what each different method showed. But again, present day, we're looking at flows of the 100-year, say around 1200, and again, mid-century is as high as 2400. So significant increase there. What does that show? So again, this is our study area. So this is the change in the floodplain from for the 100-year from present to mid-century. So what you can see here is the floodplain itself does not change that much. The most notable area is kind of this lower right-hand area here, where this bridge starts overtopping and really creates additional floodplain here and a little bit at the mouth of the Connecticut River as everything starts to spread out. But really within the reach, the floodplain is pretty close, right? And again, these are just all of the different assets, facilities within the floodplain that are being affected. But what you can't see, while the floodplain doesn't change, there's a real significant jump in velocities. So again, same area. The yellowish here are the higher velocities, and the reddish purple are the lower velocities. And as I flip between these two, you can see kind of the increase in velocity, especially down Norwich Road here, through here, and through this. This is the actor housing property here. So it's, while the floodplain might not be getting that much bigger, really you're seeing a lot more velocity, and that could cause greater impact and greater damage throughout the floodplain. And then depth. Certainly, we're looking at depth as well. So we've got a couple areas here. So this is the rehearsal studio on the left. On the left here, you've got what's shown here is the actual relative increase in the 10-year event from present day to mid-century. So again, it's a relative increase. So you're seeing a small relative increase on the 10-year and a much larger relative increase on the 100-year, in particular within the channel and this area upstream of the rehearsal studio. You're seeing significant increases in the relative flood elevation between, again, present day and mid-century. And then again, going, this is the actor housing area that we talked about. So that, for the 10-year, again, really throughout, you're seeing increases in the 10-year, and then very significant increases in the 100-year, mostly contained in the brook, but again, definitely creating more of an increase throughout the entire floodplain. And then again, Creamery Road kind of showing a similar scenario. So these are the things that, as we're trying to establish the existing conditions, what's going on, this is the type of modeling that we were looking at to really, does this support what's been seen in the past? Yes, no, and how does that apply, to how we're going to predict what's happening in the future? So adaptation strategies. So again, focusing on these three areas, this is really just kind of tip of the iceberg here. We looked at a lot of different strategies, but I'm going to focus in on these three. So the first thing we certainly recognize was the rehearsal studio and that constriction there, and really what was the issue it was causing. Second thing we looked at was how are we going to protect, what's the most economical way to potentially protect this this actor housing and residential area that's kind of upstream from Creamery Road, and then kind of looking at Creamery Road, knowing that's a constriction, like what's going to happen if we want to replace that. It's a local road. It's definitely a constriction. What are the effects of that? So these are some of our preliminary concepts here. We're actually still working on finalizing these, so you're getting to see some of the. It's not a final product, but certainly helps portray what we're thinking here. So essentially in this picture here, it's tough to see, but here's the rehearsal studios essentially right in here. So, and this kind of comes around here. What we're going to do is remove the rehearsal studio and essentially what we're calling restore, reconstruct a more natural stream bed in this area. And again, there's a lot of different work involved here. So as we're putting these together, we're coming up with essentially conceptual cost estimates too. So we got to really understand what's involved in doing this type of work. So here's just a little bit of a rendering that we pulled together, just kind of for the public to understand what it might look like in the future. So you see this channel here, very constricted on the left, and essentially we're able to widen that, armor it, give it some width, give it some depth, make it a more natural stream channel. So just an idea of what it might look like if we do remove that rehearsal studio. And really, this is the fun stuff as a modeler and as an engineer. It's like, okay, so what are the effects of that? So you can see up here, this is for the 100-year no build on the left. This is kind of what we were seeing from a floodplain standpoint, and with the rehearsal studio right here. And so if we remove that and kind of build that channel that we want to, what are the effects? The number one effect we saw was essentially this overtopping at the inlet to the rehearsal studio was causing a lot of flow to just come down Norwich Road. And essentially by eliminating that, you eliminate almost entirely the flooding of this other large facility right across the street, and as well as a significant reduction in the flooding that happens in this actor housing area and residential properties that are just upstream from Creamery Road here. So it's big effect from just removing that and essentially reconstructing a natural channel. So next we looked at, okay, well, what if we build like an earthen berm or perhaps a structural flood wall along Sucker Brook and try to reconstruct the driveway that's the entrance to the housing to kind of form more of a flood berm there to kind of keep the overtopping from the channel from spreading out into that floodplain. What would that look like? So this is a little example of that. Just a kind of another visual of what that earthen berm might look like, or the actual flood wall. We were looking at like a 6-foot height to control the flows we wanted to control. Looked at this driveway. If we raised it, what would that look like? How would that affect the parking lot that's adjacent there? So essentially you can kind of see here between these three, you're forming this wall, this berm, all the way along this border of the brook here. And really the town was really focused on implementable projects, like what can we do now to solve this problem? And there's just another view of kind of how that driveway might transition into that berm. And then the culvert, I think we looked at the culvert, I think it was 12 feet wide. I think we're going, and really to size that properly for the flows we're seeing, we were proposing really converting it to like a 24-foot span structure, likely a small bridge here, and really kind of we'd have to do some improvements to the upstream, downstream wing walls, the stream channel, et cetera, to essentially improve the hydraulics through that crossing. As you can see, you've also got a property that's really right adjacent to the crossing. So so again, just a little rendering of, you know, widening that culvert, what that might look like, and really what are the impacts. So this was really had a significant impact. So you can see now with these, with both the flood berm, flood wall, and the widening the bridge, we've essentially significantly reduced, almost eliminated the flooding in these actor housing property here. These properties that you saw those photos that were completely inundated. But we're still left with a little bit of flooding in here, which are kind of part of the further strategies that we're not really touching on today. But essentially by removing this rehearsal studio, you know, coming up with the berm / wall here and widening the bridge, we're able to really provide a lot of protection for the facilities in question. So so that's the end of the presentation. I did fly through it a little bit, but I think hopefully I covered mostly what we wanted to. And again, there's a lot of things we didn't touch on, additional mitigation strategies. We're developing budgetary costs, doing a benefit cost analysis on all these adaptations to make sure that they make sense economically, given the town, you know, our final recommendations and the priority of those recommendations, opportunities for funding, how they might pay or get certain funding programs to help pay for these projects, and kind of giving them an idea of like timelines for implementation, what to do first, what to do second, et cetera, et cetera. So it's been a fun project, and thank you, CIRCA. Thank you, Town of East Haddam, and thanks, folks, for listening to me.
Great. Thanks, Neil. So we have a couple minutes left. I don't see any questions in the question and answer. So if anybody has any questions at this point for either Beth or Neil or John or any of us, feel free to take yourself off mute or raise your hand. And I believe Mary put the Resilient Connecticut website in the chat.
Yes.
That has all our contact information. So if you think of any questions after the webinar, feel free to reach out to any of us.
I have a question, Nicole. Can you hear me?
Yep.
Yeah.
I have a question for Beth and Deb. What kind of timelines are you looking at for your project in Mystic?
Sure, that's a great question. I can answer from the point of the funding map that we're putting together, which identifies actions that could be taken in the near term, so within the next 5 years, the medium term, the next 20 years, or in the long term, the next 75 years. And so while, you know, as you move further down that timeline, it's harder to be specific about the funding structures that might be available. We are trying to identify some target funding in the near term.
Thank you.
Any other questions?
All right, I think they nailed it.
All right. So again, if you need CFM credits, please email me. Again, Mary put my email address in the chat. I know I've seen a couple emails come in already, but if you haven't emailed me, please do so. And thanks everybody for being here.
Yeah, and thank you, Beth and Neil, and both of your teams for you know, available for this today and for all the work you've been doing through the program.
Thanks for having us. Great to be here.
Thank you.
Thank you.
All right.
Thank you, everyone.
Bye-bye.